Fascinating Frontiers, episode 146, coming to you on July 30th, 2026. The universe has been busy. Let's get into it. Webb is tracing how the universe's earliest mysterious red objects may have simply grown into the galaxies around us today. Little red dots first appeared in Webb data as compact, distant sources that emerged around 600 million years after the Big Bang, and seem to decline sharply by roughly 1.5 billion years after the Big Bang. New analysis indicates these objects did not vanish, but instead developed into the central regions of more familiar galaxies. Researchers combined Webb infrared observations with Hubble ultraviolet and Chandra X-ray images of a spiral galaxy already in place 3.3 billion years after the Big Bang. The galaxy's compact central source meets every criterion used to identify little red dots, yet its proximity allows clear views of the surrounding disk and arms. When the same galaxy is artificially placed at higher redshift, the extended structure fades from view and the object becomes indistinguishable from the distant little red dot population. This work sits within the ongoing JWST effort to understand early universe galaxy growth that we discussed yesterday. The Cosmic Spotlight this week focuses on those same Webb observations of little red dots. The data suggests these compact early objects may simply be the dense cores of galaxies that later grew extended disks and arms. By shifting a nearby spiral galaxy to higher redshift in simulation, researchers showed how its outer structure would vanish from view, leaving only the red central source. The work tightens the link between the mysterious early population and today's mature galaxies. What remains unclear is whether every little red dot follows this evolutionary path or whether some represent a short-lived phenomenon that truly disappears. Now shifting to Boeing's capsule. Boeing's Starliner capsule sits closer to a second crewed test flight than many observers anticipated after the initial mission. Engineers continue to assess helium leaks and thruster performance recorded during that flight. A successful uncrewed demonstration could open the door for astronauts to ride the vehicle back to the station before the end of the year. On a different note, a Falcon 9 lifted off from Cape Canaveral Pad 40, carrying the National Reconnaissance Office payload designated USA-619. The mission inserted the Signals Intelligence satellite into a 63-degree orbit. The first stage touched down at Landing Zone 2 roughly 8 minutes after liftoff. Next up, China completed 2 launches in one day. A Long March 6A lifted off from Taiyuan carrying the Tongshin Jeishu Shiyan 27A and 27B satellites. Earlier the same day, a Long March 7A had sent the Tianlian 301 data relay satellite from Wenchang into geostationary orbit. Sea surface salinity measurements from the SMOS mission are revealing freshwater and salt patterns across the Pacific that appear before temperature shifts become obvious. These salinity changes could serve as an earlier indicator of developing El Niño conditions than sea surface temperature data alone. A Falcon 9 upper stage will impact the lunar surface on August 5th. Scientists intend to examine the resulting crater and ejected material to learn how human-made objects modify the lunar surface environment. The French startup Maya Space has abandoned earlier plans for a suborbital demonstration flight. Development focus has shifted directly toward an orbital version of its reusable first stage. Students at Johnson Space Center are working on flight hardware, mission planning, and public communication for ongoing human spaceflight programs. Their projects range from habitat design concepts to real-time operations support. Sophia Space and Caltech received a patent covering modular, large-scale data centers designed to operate in space. The architecture aims to reduce latency and energy demands compared with terrestrial facilities. A new theoretical method combines quantum algorithms with coronagraph techniques to suppress starlight and reveal planets up to 10 billion times fainter than their host stars. The approach targets the specific noise properties that currently limit conventional imaging. If every star were a searchlight, an Earth-sized planet would be a firefly hovering just outside the beam. Yet the firefly still blocks a few photons. Quantum imaging exploits the fact that entangled photon pairs carry correlated information even when one photon never reaches the detector. By measuring subtle interference patterns between the collected starlight and its entangled partner held in the instrument, astronomers can in principle subtract the star's glare more cleanly than any classical coronagraph allows. The technique requires maintaining entanglement over the long baseline between telescope and spacecraft, a distance measured in tens of thousands of kilometers. Laboratory demonstrations have already shown contrast improvements of several orders of magnitude at visible wavelengths. The open question is whether the same correlations survive the turbulence and thermal noise of a real space telescope operating for the years needed to survey hundreds of nearby stars. Maintaining phase stability across such distances while rejecting stray light from the host star remains an engineering barrier that has not yet been crossed in orbit. Even a modest improvement in contrast would let future missions examine the atmospheres of Earth-sized worlds at separations previously considered impossible to resolve. Researchers applied a new stacking algorithm to optical surveys and detected previously invisible fragments in geosynchronous orbit. The technique aligns multiple short exposures to bring faint objects above the detection threshold without prior orbit knowledge. Orbital radar and thermal data are being combined to estimate regolith depth at candidate south polar landing sites. Thicker layers provide better radiation shielding, but complicate excavation for habitat foundations. Ground-based radio arrays are now monitoring both active satellites and defunct rocket bodies by detecting their reflected signals. The method works day and night and through cloud cover that blocks optical sensors. NASA has identified South Korea as a primary international contributor to the Artemis lunar base architecture. Joint work will focus on power systems, communications, and resource utilization technology. China's coastal spaceport completed its 50th mission with the recent Tianlian 301 flight. The site now supports both crewed and heavy-lift cargo vehicles. Keep an eye on the next uncrewed Starliner test flight, which could clear the way for a crewed attempt before the end of the year. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. One more thing. If you like today's episode, our sister show, Planetarian Daily, is worth a spot in your feed. Daily breakthroughs in science, health, and longevity. It's one of the NERA Network's daily briefings, all free at neranetwork.com. And on the website, every episode's visuals live in our free image gallery at neranetwork.com/gallery. Royalty-free under Creative Commons, download with attribution. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.